5.8, module 5.8, to function or not to function. So we're practicing here, so we should know what is a function and what is not a function. And now we're going to take a look at some different relationships and decide are they or are they not, and provide some reasoning behind it. Okay? So remember, we have three rules if something is a function. The first is two groups, which typically we have that. That's pretty easy. We don't usually judge that one. The second is a pattern. Okay, usually we don't worry about that too much. These two rules are kind of like, yeah, they are easy to show, so we don't really deal with them. It's that third rule, that one-to-one. Okay, that's what we really are looking for here and trying to decide for every input. This is what one-to-one means, right? For every input, only one output. So if I can come up with a situation when there's more than one output, I know it's not a function. And that's a good way to try to justify it. Okay, so let's think about this. Number one, a person's name versus their social security number. So let's think about it. So the input here is your name. The output is your social security number. Now, we know that every single person in this world has, well, not world, I guess, but in the United States, has their own unique social security number. Everybody does not have their own unique name. So the question is, can I find two people with the same name with different social securities? Yeah. What about somebody named, I don't know, Anderson? That seems like a pretty common name. Or Johnson. Johnson, yeah, I live by three different families with Johnsons. And two of the boys, well, the father and one of the boys and another, both have the first name Josh and the last name Johnson. Do they have the same social security? No. So I give you the input of John Johnson. Can you go in the whole United States and find different outputs for that? Yes. So not a function. We'll just write NF. Why is it not a function? That is my reasoning. Can find people with the same name with different social security numbers. Okay. Now look at number two. Now we're flipping it around. Now we're saying the input here is the social security and the output is the name. So once again, can we find two people with the same social security number? No. Can they have the same name? Yes. But the input now is a social security number, so for this one, it is a function because of that reason. Because if I give you a social security number, you can only give me one name. Now, two different social security numbers can give me the same output. That's like the vending machine all being Snickers. That's all right to have. Okay, that one is all right to have. All right, number three, the cost of gas versus the amount of gas pumped. Okay. So the cost of gas, so our input here would be the cost of gas. The output would be the gas pumped. Okay. So let's think about this. Think about here in Tooele. We've got Chevron on one side of the street, Holiday Oil on the other side. So if two separate cars pull in there, okay, and they both spend 20 bucks on gas, are they going to have the same amount pumped? Well, it depends, right? Typically, these two don't have gas at the same price. So if their gas isn't at the same price per gallon, this would not be a function because you're going to have the same cost, 20 bucks, but they both did different amounts. The only way this would be a function is if over the years, over the days, over the minutes, at different gas stations, if it was, the same cost. So we're going to call that one not a function because there's too many variables that would cause it not to work. Okay? Alright, let's look at number 4. These ones are easy, right? Look at your input. 3, 4, 8, 4. Do we have the same input? Yes, 4 and 4. Do they have different outputs? Nope. So this one's a function because of that. Okay, number 5, the temperature in degrees with respect to the time of day. So with respect to. So when we say it that way, with respect to, it means this time of day is like the independent variable, so that's our input. So at the time of day, the temperature in degrees Fahrenheit. So the degrees. Okay, so how many times of days can we have? Well, on Monday we had, let's say, noon. On Tuesday we also have noon. On Wednesday we also have noon. Okay, so if I just say noon, throughout the year, are we going to have the same degrees? No, noon could give you different degrees, whether you're talking about winter, summer, spring, fall. Therefore, we're going to call this one not a function, because they're not telling us which day. And even if you look at between the days of the year, always in winter, each day in winter is not the same. Okay, so not a function. Okay, look at 6. So let's look at our input here. Do we have the same input? 6 and 6. Do they give us the same output? No, not a function. That one's easy peasy. Okay. Alright, let's look at the next group. So, the area of a circle as it relates to the radius. Okay. So the area of a circle as it relates to the radius. So, which would be our input, which would be our output, because that's kind of what it depends on. Okay. So as it relates to is telling me that the radius is probably the input. So if I give you a radius on a circle, okay, could we have different areas? And the answer to this is no, because it would be pi r squared. And we can't do a negative radius equals the area. If we could do a negative radius, that would work, but because we can't, that radius determines the size of the circle, and therefore the area, so function. Okay, number 8, different inputs giving us each a specific output function. Doesn't matter that these two are the same, because whenever I give you 5, you give me, or 3, you give me 5 back. Whenever I give you 5, you give me 5. It's determined, it's always going to be the same. Okay. Now 9, the radius of a cylinder is dependent on the volume. So the volume here would be the input. The radius of a cylinder would be the output. Okay. So if I give you a volume, will we always get the same type of cylinder? The answer to this is no, because there's another factor, the height. I could have a taller, skinnier one with a different radius than a shorter, fatter one, but they could have the same volume. So because of that, not a function. Okay, number 10, the size of the radius of a circle depends on the area. So the area, again, is the input. The radius of the circle is the output. Now once again, with a circle, okay, there's only the one factor, the radius. Pi stays the same, it's just the radius. So this one would be a function because there's nothing else. Like with the volume, you had two variables, the radius and the height. Because of the two variables, you could have different outputs for the same input. In that case, for this one, no. For just a circle, no. So it's still a function. Okay, 11. Student's letter grade dependent on the percent earned. Okay, so the percent earned is the independent variable, or the input. So like 70%, and the output would be the letter grade. Okay, so in my class, a 70% gives you a C minus. A 71% gives you a C minus. Okay, so if we're talking about one teacher, then the answer would be yes, it's a function. Okay, if it were flipped, you get a C minus, you could be anywhere from 70% to 73%. So it wouldn't work on the flip side. But in this way, yes, it is a function. Because of that, now if we're talking about, if we extended it to multiple teachers, that's where we could get the no function, if we had multiple teachers. Because some teachers grade differently. But we'll say just for one teacher. Okay, number 12, the length of fence needed with respect to the amount of area enclosed. So with respect to tells me that the amount of area to be enclosed, okay, the area is our input, the length of the fence is our output. So once again, because area deals with two sides, length times width, right, there's two variables. okay? Not just the length. So because of that, we would call this not a function, because I can have a really skinny one with the same area as a more squarish one, and that's going to have a different amount of length. So not a function for 12. Alright, so the last three, the explicit formula for the recursive situation below. So f of 1 equals 3, f of n plus 1 equals, so this is the next, is equal to the current plus 4. So if I made a table of that, 0, 1, 2, 3, that would be 3. We would add 4 each time, right? So that would be 7. That would be 11. So looking at this, it's arithmetic, right? It's linear. We should know that linear equations are always functions because it's not vertical. Okay? The explicit would be f of n equals negative 1 plus 4n, or 4n minus 1. So it's never going to give us something. Linear is always a function. Okay? Number, let's do 15 real quick. Okay, the national debt with respect to time. So time is my input, the debt is my output. So if I give you an input of time, say next year, will the national debt be more than one possibility? No, so it's a function. Because that time keeps moving and the debt is either going down or up. It's not, you can't have two debts at the same time. Well, in real life you can. You can have owe debt to two different people, but for the national debt, that's just one number. Okay, so number 14. If x is a rational number, then f of x equals 1. If x is an irrational number, then f of x equals 0. Okay, so the idea here is rational numbers are like the regular numbers, negative 2, we call these the real numbers, negative 1, 0, 1, 2, and so on. Okay, and it's also fractions that end, like 1/4, that's 0.25. 3/4, that's 0.75. 1/8, that's like 0.825. No, it's point like 125 or something. So anything that's a fraction with whole numbers, like 5/10, that's 1/2. Those are called rational numbers. So my input is all these numbers, my output is 1. Okay? So an irrational number would be like pi. It's a decimal, 3.14, that just keeps going. It's not repeating decimal. Because even repeating decimals, like 1/3, 0.333333 repeated, that's still rational. Irrational would be like the square root of 2, 1.7, blah, 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 blah. Okay, so there's a lot less irrational numbers, but any irrational number is 0. So the only way for this to work is if we had one that was both irrational and rational, which we don't, which could then give us two different outputs. It can't, so this is a function. And there we go. Hopefully you guys are ready to take a look at those on the test and do well.